so now this is an application of doing the whole thing, setting it up, graphing it. So this first example is a bounded case, and then my last example will be an unbounded case. So this is putting it all together. All right, so I have an animal rescue shelter that is required to provide each animal with at least 30 grams of protein, at least 36 grams of fat, at least 24 grams of fiber. All right, the nutrients will come from food A and food B. Each unit of food A costs 20 cents, provides 2 grams of protein, 8 grams of fat, 2 grams of fiber. All right, each unit of B costs 30 cents, provides 6 grams of protein, 2 grams of fat, 3 grams of fiber. I might determine the units of each type of food that should be used per day in order to minimize cost. So there's my objective. All right, so first thing is this last line gives me my variables and my objective. Right. Each type of food. So I've got food A and food B, generic foods. All right, so I'm going to let X be a unit of food A. I'm going to let Y be a unit of food B. I'm going to change my color because I think those are light. All right, my objective is to, well, they actually came out and told me I want to minimize cost. All right, so I'm going to let C be my cost. All right, so the cost, they actually told you right away. Food A cost 20 cents. Food B cost 30 cents. So it's in cents. So keep that in mind, it's in cents. And so I've got my X and my Y. And so my X goes with, so I'm going to kind of put them up here because X goes with A and Y goes with B. Alright, so it costs 20 cents for every unit of X and 30 cents for every unit of Y. And so there's where my objective is. And so I'm going to hold that off. Again, keep in mind it's in cents and save that for later. I'm going to put that in my table and figure out that after I find my feasible region and find my quarter points. All right, now the constraints, right, which are the at least parts, right? And so that's what I'm going to write down first. So I want at least, before I get started, I'm going to remember that I have to have positive values only. So you have to remember to include those. If it's not like that last example I did where they gave me at least so many units of Y and so many units of X that they had. This one doesn't. This one just tells me how much protein, how much fat, and how much fiber. It doesn't tell me I have to have so much of food A and so much of food B. All I know is I'm going to have food A, food B, and they have to be positive, right? I can't have negative food A. It doesn't make any sense. I can't have negative food B. I could have 0. I could get all of food A, which would zero out B, or all of food B, and it would zero out A. But I have to have positive amounts. All right. So remember, it's really easy. If I'm going to forget something, I'm going to forget those what we call implied inequalities, right? My values have to be positive when I go to graph them. Right, then I have my at least so much protein, so now I'm going to write down my at least 30 grams of protein. You can read that. At least 36 grams of fat. And at least 24 grams of fiber. Ugh, grams. Alright, so this is going to be an unbounded case. I think I said bounded case at the beginning of this. This is going to be an unbounded. I know it's unbounded because of the at least, meaning I'm going to shade below all of these. And so it's going to be unbounded. But we'll get there when we get there. Alright, at least, remember, means maximum. I want that amount or more. Right? This is the number or more. I want my number to come out that amount or more. And so my equation represents my food, right? So I want my food, A and B amount, to come out 30 grams of protein or more. And so greater than or equal to are what all of these are going to be. Greater than or equal to 30, greater than or equal to 36, greater than or equal to 24. And then I've got my equations that involve x and y's, and I've got to fill in the numbers in front of those that have to do with each of the protein, fat, and fiber. Alright, so we'll start with protein. So X represents food A, Y represents food B, and I want the protein for food A and B. So X represents food A, has 2 grams of protein, Y has 6 grams of protein, so 2 and 6. Right, now I do the grams of fat. So X has 8 grams of fat, Y has 2 grams of fat. 8 and 2, and then the last would be fiber. X has 2 grams of fiber, and Y has 3 grams of fiber. So 2 and 3. And then my check. I'm going to erase my lines underneath that so I don't confuse myself with them. Alright, so the X should go 282. Protein, fat, fiber. 282. So I'm going to go back and look at my X. 282. Protein, fat, fiber. My Y should go 623. Protein, fat, fiber. So 623, and I'll check it. 623. And so that's my check. Alright, and then I also have to have the positives. Alright, so there are my equations. Right, there is my system that I'm going to have to graph, shade, find my corner points. And I do the fact that I know these are all going to be greater than cases. The solution set's going to be above, and so this is going to be an unbounded case. But we'll do that when we get there. All right. Now we're going to graph it on my grid. So I'm going to kind of do my work up here. So I'll start with my first equation, and I'll do it in blue. I like to do different colors, so I encourage you to do that as well. There is grid paper that you can print off and use. You can either use the stuff I've posted in Reginet, or you Google grid paper, and there's all different kinds out there on the internet that you could copy or print and use. Alright, so this is my first equation. So again, find my intercepts because they're often going to be my corner points. So x equals 0, and then I've got 6y equals 30, divide by my 6, so y equals 5. Alright, and then my same spot. Y equals 0. I get 2x equals 30. And so x is 15. Right, and then I'll do my test after I graphed it. Although I'm pretty certain I'll be testing 0, 0. Alright, graph those 2 points. So go to my grid. I'm graphing already. 0, 5, and 15, 0. Alright, so 0, 5 puts me here, and 0, 15 puts me there. Alright, so I want to make sure I'm careful. And I connect my dots. Alright. And then this is my, I'm going to label it, so this was the 2x plus 6y equals 30. 2x plus 6y equals 30. Now I'm going to pick a different color to draw my next line. So I'm going to pick my second line. I'm going to draw it in red. So line 2, which would be 8x plus 2y equals 36. Same song and dance. Find my intercepts. So x equals 0. I get 2y equals 36. Is 18. Y equals 0, 8x equals 36. So that's 4.5. 4.5, if you wanted to pick a different point because it doesn't come out real nice, but it's just a half point, so I'm probably going to use it. Oh, and I forgot to do my test on my last one. But I know the test is going to come out 0, less than or equal to, greater than or equal to, which is false. Alright, the 0, 0 is going to come out false for all of them, right? If I plug 0, 0 in, these are all going to 0 out, which is going to be false for all of them. So I'm always going to shade on the 0, 0 side. I am going to leave the above side unshaded, right? Because again, I want to go bigger. I'll write that down in a second. Alright, so first graphing this though, 0, 18, and 4.5, 0. So 0, 18 puts me way up here. And 4.5 puts me right in between 4.5. So remember, 4.5 is that point. 4.50. So it's going to be a harder graph. Oh, somehow those are the sides that I have trouble with graphing. Alright, so there's my red line, which is 8x plus 2y equals 36. And I know that one's not real pretty. Alright, so that one's not good. That one I'll probably have to definitely check whatever it is. But again, for both of these, I'm going to shade below. Alright, so for both of them, because the 0, 0 is going to be false for all of them. So all of my lines, I'm going to shade below. Same thing for my third line. Alright, so my third line, let me find a different color. Oh, let's go green. Alright, so my third line is 2x plus 3y equals 24. So 2x plus 3y equals 24. So again, I'm going to pick my zeros. So x equals 0. I've got 3y equals 24 divided by 3. So y equals 8. And then y equals 0. I get 2y equals 24. 2x equals 24. Sorry about that. X equals 12. Alright, so for my third line, 0, 8, and 12, 0. So 0, 8, and 12, 0 puts me there. Alright. So my green line. Which is 2x plus 3y equals 24. So 2x plus 3y equals 24. And again, I'm going to shade below because the 0, 0 is false for all three. Alright. And then I'm also missing some lines here, so I'm going to go ahead and put those in before I start shading. So remember, my x-axis is a line, right? That would be the line y equals 0, and I've got a shade below that. And I've also got the y-axis as a line, x equals 0, and I've got a shade to the left of that. Right? I only want positive numbers. And so I'm shading everything to the left and the below of my line. So shading everything below and everything to the left. And so this is unbounded. Right, because it's the area above and to the right, right? Unbounded, it's shooting off for forever. There are corner points, which again, this time I'm probably going to have to find them because I'm not sure if I graphed them very good. Two of them are pretty easy though. This is a corner point at 0, 18, so I'll call that corner point A, which is at 0, 18. I've got a corner point here, that's B. Got a corner point here, that's C. Oops, I need to erase that. Corner point here at D, which is the point 15, 0. Alright, so D is easy. B and C, because I know my graphing didn't come out great. Either graph them, find where they intersect, or solve the system. Well, if I look at it, I'll ballpark it and see if it is. That looks like it's at 1, 2, 3, 6, 3, 6. C looks like it's at. Yeah, C's kind of all over. All right, C really, I really can't tell. I did a very poor job of graphing both of those lines. All right, so Z is kind of unknown right now. All right, I'll have to figure out where the green line and the blue line meet when I go to find C. All right, so right now C is unknown. Oh, yeah, I think I just did a horrible job of graphing because I don't think it looks like it's even in the ballpark of where I think it should be. All right, so my corner points. My corner point A, B, C, D. A and D I know. Alright, A is the corner point 0, 18. I don't have to check that, so I'm just going to leave it. D was the corner point 15, 0, and I don't have to check that because, again, I use those to graph. B and C, B I could kind of guess maybe. C I have no idea. And so B, so this is why I kind of need to know what lines they go through. Alright, so B goes through, the point B goes through the lines. The red line and the green line. Alright, so B, I need to solve the red line and the green line. So my red line was 8x plus 2y equals 36. My green line was 2x plus 3y equals 24. And I'm just going to plug them in a matrix and row reduce instead of trying to guess what it was. Alright, so I'm just throwing this in a matrix and going to row reduce to find out what that point was, what my point B was. Alright, so when I do that in, give me a second while I type it out. Alright, did come out 3, 6. So that one actually was at least in the ballpark. Alright, so B was the point 3, 6. Alright, C, which again I don't think I was anywhere near because I think I drew those lines really well. So again, C I have to solve. C goes through the blue line and the green line. So my blue line was 2x plus 6y equals 30. And my green line was 2x plus 3y equals 24. And again, I am just going to use a matrix. So I'm going to plug that in my matrix, row reduce, and find my x and my y. Alright, give me a second while I type those in since I did a very poor job graphing. So I don't even think I came close. Nine, 2. So C was the point 9, 2, which, yeah, didn't even come close. 9, 2 would put me here. Well, the blue line at least went through it, but my green line didn't come close at all. Alright, so C should have been at 9, 2. And since I did my work above, I'm not going to write the equations out. Alright, so there are my corner points. 0, 18, 3, 6, 9, 2, and 15, 0. Right, now I go back and get my objective function, so I'm going to write my objective. So my objective was to minimize cost, and there's my cost equation. So 20x plus 30y. Alright, so cost equals 20x plus 30y. And we want to minimize. So again, take all of my corner points, plug them in there, and find the cost. So take each one of those, plug them into that cost equation. So take 0 for x, 18 for y, so it's going to be 30 times 18, which is 540. Cost at 3, 6, so plug in 3 times 20, 6 times 30 comes out to 40. 9 times 2, 9 times 20 plus 30 times 2, also comes out to 40. And 15 times 20 comes out 300. So I have two minimum, well I have one minimum, but they occur at two different values. Alright, so my optimum solution is, remember, cost is in cents, if you remember. Alright, so they can minimize the cost of the dog food by having the units of dog food. Alright, so the cost is minimize at 24 cents per unit. But there are two outcomes. There are two ways to make that solution happen. So the minimum cost is 240 cents. Right? $2.40 per unit. You can write it that way too. But there are two options. So we have two options to make it happen. So remember, X represents the brand A food, B represents the brand Y, or Y represents the brand B food. Alright, so when they have 3 units of the A food and 6 units of the B food, or, so that's one option, or 9 units of the A food and 2 units of the B food. Both of those blends will give me the same minimum cost, right? And the same will fall in the same feasibility, meaning the dogs will get the right amount of protein, the right amount of fat, and the right amount of fiber. Right? Because that's what we remember that we were looking for. We have to blend our food so we get so much fiber, so much protein, so much fat. And so both of those will give me the right amount of fat, fiber, and protein. And both of them will give me a minimum. And so then I have to choose. What it would come down to is the first version has more B and the second version has more A. So you'd either figure out, well, which one do the dogs like better and go with the one that they like better. So whichever one, if they like brand B better, you'd go with the first option. If they like brand A better, you'd go with the second option. Or whichever food is easier to get. Right? Sometimes it's easier to find one brand over the other. But this allows them two options. Right? They're going to minimize cost in two ways. Right? So there's an example of an unbounded case, which means the last example is a bounded case. Right? So that's a putting it all together problem.